let's do question number 1. It says that f of x is x squared minus 3x plus 5 when x is equal to 2, right? Yeah. And so we're going to have the limit as x approaches 2 of f of x minus f of 2 over x minus 2, which is going to be equal to the limit as x approaches 2. F of x is x squared minus 3x plus 5. Now, if you want to stop me at any point, by all means, stop me, okay, and ask a question. But I'm just going to plow through them if you don't have any questions. All right, minus whatever f of 2 is over x minus 2. All right. So to find find f of 2, I'm going to put a 2 here. 4 minus 3 times 2 is 6 plus 5. So 4 minus 6 is negative 2. Negative 2 plus 5 is 3, so it's minus 3. And it's positive 5 minus 3. Positive 5 minus 3 is positive 2, right? So this is going to become plus 2. Now I'm going to do you don't have to do synthetic division. You could factor this. This is an easy one to factor, but we'll do synthetic division because I've trained y'all to sort of jump into synthetic division at this point. So we'll put a 2 in the half box. We've got 1, negative 3, and 2. Bring down the 1, times 2 is 2, plus negative 3 is negative 1, times 2 is negative 2, plus 2 is 0. So we've got our remainder of 0, which is what we wanted. And this is now 1x minus 1, so that's x minus 1. So what this factors into is x minus 2 times x minus 1. The x minus 2's are going to cancel, and all we have left is x minus 1. And so now the limit as x approaches 2 of x minus 1, well, we'll plug the 2 in, and 2 minus 1 is 1. So the instantaneous rate of change is 1. Right? The slope of the curve when x equals 2 is 1. Okay? We're good? All right. Let's go on to the question. Let's jump ahead to 4. Let's jump ahead to question number 4, which I think is what? Is that one r of x or? Yeah. No, it's f of x. We'll do 5 also. All right, let's look at 4. Number 4 says that f of x is 3x squared minus x plus 4. Are we challenging the mic? Is that what we're doing? We're trying to find out if the... Yeah. All right, where x is equal to 0. Now, this problem, I need you guys to understand, when we do where x is equal to 0, this actually makes the problem easier, not more difficult. Okay? Let me show you why it makes it easier. So let's set up our limit. We've got the limit as x approaches 0 of f of x minus f of 0 over x minus 0. So let's write it again, the limit as x approaches 0. Well, what is x minus 0? It's just x, right? So now we have f of x is 3x squared minus x plus 4 minus whatever f of 0 is over x minus 0, which is just x. Now, if I plug 0 in here, what do I get? 4. 0 minus 0 plus 4 is 4. And what is 4 minus 4? 0. So actually, we don't even have a constant, we don't even have a c value on this. And now, right, and if I plug a 0 and I get 0 over 0. Now, synthetic division doesn't make any sense here. Now, I'll do synthetic division just to show you, but look, we can factor out an x. The factoring here is the easiest kind of factoring you can do. Take out a greatest common factor. We can take an x out of here and an x out of here, and that becomes x times 3x minus 1. I know you guys don't do this much. I don't know why they don't. This is probably one of the most important skills in all of algebra, is greatest common factor, but they don't make you do it. You know, they don't give you enough of these problems. Once I factor out an x, what can I do? I can cancel an x in the top and the bottom, and all I have left is 3x minus 1. And now when I plug 0 in, it's negative 1, because 3 times 0 is 0, and 0 minus 1 is negative 1. Yeah. Now, if you use synthetic division, All right, watch me do synthetic division here. If I put a 0 in the half box, and then put a 3, a -1, and a 0, because I have to represent everything, right? Now I'm going to carry down the 3, times 0 is 0, minus 1 is -1, times 0 is 0, and 0 plus 0 is 0. There we go. And look, 3x minus 1, which is right here. Same thing, right? And let's say you wanted to do synthetic division now, right? So let's put a 0 here. Carry down the 3. 3 times 0 is 0. 0 plus -1 is -1, and that's our answer. Okay? So the slope of the graph of this has a slope of -1 when x is equal to 0. Okay? All right, let's do, I'll tell you what, let's do 5, because you guys said, oh, I want to do 5 too. So let's do 5. Did you like my impression of all of you? Oh, I want to do 5. Yeah. All right. Question number 5. We've got r of x is x cubed minus 3x squared. Then we've got plus x minus 5. Okay? Where x is equal to 1. All right, guys, listen. Guys, are you with me? Okay, so I'm going to do the limit as x approaches 1 of r of x minus r of 1 over x minus 1. All right, so limit as x approaches 1. R of x is x cubed. You got -2? Yeah. For when you plug in? Okay, minus 3x squared plus x minus 5 minus some output value over x minus 1. And did everybody get -2 when you plug in 1? -6. Oh, -6, sorry. Okay. Oh, I see. Yeah, got it. Okay. So 1 minus 3 is -2, plus 1 is -1, minus 5 is -6. So we put a -6 here. What does minus -6 mean? Plus 6. And what's -5 plus 6? +1. So this... Yeah.
How you doing now? Can we do that?
Yeah, that's fine. Yeah, you can just write it here. Like, you can skip the step where you show that other thing if you want. That's fine. Now, synthetic division. I'm going to put a 1 in the half box. I've got a 1 here. I've got a -3 here. I've got a 1 here, and I've got a 1 here. Carry down the 1. Times 1 is 1. Minus 3 is -2. Times 1 is -2. Plus 1 is -1. Times 1 is -1. Plus 1 is 0. And so what this now is, this is now x squared. Go ahead. Oh, it should be minus 2x. Okay, sorry. And then minus 1. There we go. So this is our other factor. So this now factors into x minus 1 times x squared minus 2x minus 1. Cancel the x minus 1. Plug in 1 in for x here. So x squared. 1 squared is 1. Minus 2 times 1 is minus 2 minus 1. 1 minus 2 is -1. Minus 1 is -2. There we go. And you might have done synthetic division. You might have put a 1 in the half box here. Carry down the 1. Times 1 is 1. Minus 2 is -1. Times 1 is -1. Plus -1 is -2. Remainder theorem. And we're good.
I think using that's easy.
Well, it is. That's what. But I don't think very many people, math teachers included, are into this remainder theorem thing, this synthetic division thing. Oh, sure you can. Oh, no. I promise you, your professor will probably recognize the value of synthetic division. Probably. Okay? If they ask you, hey, what are you doing there? Look up the remainder theorem, bring it to them and say, oh, it's the remainder theorem. You can use division, polynomial division, to plug in a number. Yeah. Okay? All right. Let's now do number 6. I think we have enough time to do number 6. Number 6, question the equation of the line tangent to the graph. Austin, will you go over there to that coffee urn and plug it into the plug right next to it? Thank you. All you got to do is plug it in. That's it.
Are you going to put that on there?
Yeah, it'll probably be on there. Say it again.
Not get on the camera, like not get into the
Let's plan that for another time. Thanks for asking, though. But I will say your name, Maya. I will say your name. Shout out to Maya. Okay.
Shout out to Maya.
All right. Question number 6. What is the equation of the tangent line, or the line tangent to the function f of x, where f of x is x squared minus 3 at x equals 3? Okay, so x squared minus 3 is the function. At x equals 3, what is the instantaneous rate of change? Well, excuse me, what is the equation of the line tangent to the graph, which requires a point? So we have x equals 3, y equals, well, let's plug 3 in. 3 squared is 9, 9 minus 3 is 6, right? Now we need an instantaneous rate of change, which is the slope of the tangent line. The limit as x approaches 3 of f of x minus f of 3 over x minus 3. Now, f of x, so we get the limit as x approaches 3 of whatever f of x is, x squared minus 3, minus the output value, which we already calculated as 6, right? Oh, it is a difference of squares, isn't it? It sure is. Over x minus 3. This now becomes negative 3 minus 6 means minus 9. So this is actually x squared minus 9, which factors into x minus 3 times x plus 3. You could use synthetic division if you want to. I'm not going to right now, but you could. Cancel the x minus 3's, and now plug the 3 in, and 3 plus 3 is 6. So, don't get confused here. This will not always happen. However, in this particular case, the y value is 6 at this point, and the slope is also 6. It happens sometimes. Yeah. Y minus 6 equals 6. That's it. There you go. There's the equation of the line. Okay. It should be. Say again? Oh, yeah. Guys, the answers. Oh, you know what? I don't have an answer sheet, but I can still, because I know how to do these in my head. All right. Guys, yeah. It's a coincidence here. Now, okay, I'm going to use the phrase coincidence. Technically, it's not a coincidence, but for now, let's just say it's a coincidence. I don't want you to create some sort of inductive pattern in your brain that the slope and the y value are always the same for some weird reason in some situation. Now, that will be true in certain situations, but I'm not trying to teach you that right now. Does that make sense? It's just, we're going to call it happenstance that we came up with the same number for the y and for the slope. Okay? All right. So we did questions 1, 4, 5, and 6. However, I did not give you the answers to 2 and 3, so let me go ahead and do that now.
Okay.
Number 2 should be... It should be 0. Oh, wait, hang on. Yes, it's 0. Should be 0. Yeah. So number 2 should be 0. Yes, okay. Number 3 should be 7. Yep. Very good. Yeah. I think that too. I really do. I think calculus is actually easier than, I know this is going to be weird to say this. To me, calculus is easier than algebra, even any kind of pre-calculus or algebra, because calculus operates on, you don't need to memorize formulas usually. There are some rules you have to memorize, but formulas you usually do not have to memorize in calculus. Okay, this is a formula, and you're like, well, yeah, but I got to memorize this. We're actually in about a week or so, we're gonna get rid of it. We're gonna stop using this, and we're gonna move on to a rule, and it's gonna work every time. Okay. All right. Hey, folks. Now we got just enough time. Hey, folks. Can I have your attention, please? We have just enough time for a lesson. So you're about to take notes, is what you're about to do. Okay? So here's what I'm going to do. I'm going to erase this. And what I want to do is, I would like to refer back to the first practice problem that you did today. Not on that sheet, but the one I had you do at the beginning of class. Wasn't it x squared minus, thank you, go ahead. Plus 8. Yes. Shout out to Maya. Yeah. You didn't get it, Danielle didn't get a shout out? Shout out to Danielle. That's right, for the difference of squares. All right, so how are we doing? Are we good? Okay. So here's your question. I want you to listen. I want you to listen to this question, please. Because where we are going from here, we are at a critical point where we are about to enter the world of calculus becomes easier. Okay? Do you remember? Yes, easier. Do you remember the other day? Okay, when I say the other day, I mean like Tuesday. Do you remember we did a function and we identified a bunch of instantaneous rates of change, but we did different x values for the same function? Remember that? Yeah. And we learned that the power goes down. Yeah, there's a pattern, right? That our instantaneous rate of change follows a pattern that is 1 power less than our function, right? So here's what I want to do. I want you to imagine, see, that day when we did 5 different x values, we did a separate new limit for every single number. Right? Wouldn't it be nice if there was a way to not have to do a new limit every single time? Do you agree with that? What if you identify the pattern? What if you identify some sort of formula so that all you had to do was pick any x value and plug it into that pattern and get the final answer? This would be a good thing, right? It would save time in finding instantaneous rates of change. Well, a way that you can do that, let me put our formula here. The limit as x approaches c of f of x minus f of c over x minus c. All right, are we ready? Limit as x approaches c. So this is our definition. This is our formula and definition for the instantaneous rate of change at point x equals c. Right? Yes, sir. Yes. Mm-hmm. Here. Can you hand this to? Here, let me do this. I need a pen.
Are you going to cut some of these parts out in the video?
Maybe. Maybe not. It's okay because you're... No, I'll leave the shout out in, of course. Okay. Trust me when I say that it's much easier to watch the video when these little breaks are in, because your brain gets relaxed is able to take a break for a second and then come back. There are people who are not in here today, and you may want to watch this video.
Oh, I thought you just wanted to make some
Yeah.
YouTube money.
No. I do these for free, just for people to learn. Yeah, I know, but I make enough money. I'm good. And I said that on video. I know I said that on video. I make enough money. All right, guys, pull it back. So listen. Hey, guys, I don't want to run out of time. So here's the deal. A way to create a formula. In fact, this is oftentimes one way to make formulas mathematically is to solve something like this without putting a number in. In fact, what we're about to do is we're about to identify the instantaneous rate of change in this function when x equals c. Now, do you know what's going to happen when we do that? When we don't put a number in here, when we just leave the letter c. The answer we get, guess what's going to be in the answer?
C.
A c. There's going to be a c in the answer. And then guess what we can do when we want to know the instantaneous rate of change when x is equal to 4? What's that? For what? Wait, right, but for what letter? For c. We could just put that number, that x number, into the c and have the instantaneous rate of change. Does this sound like a good idea?
Yeah.
That will save us time, right?
Yeah.
So here's what we're going to do. Are you all ready? Because here's what we're going to do. So what would we normally write next? Well, normally we would write the limit as x approaches c. You're going to have to sit somewhere else, Jeremy. Yeah, that'll work.
Hey,
Yeah.
Fran.
Okay, so we've got the limit as x approaches c of what? What would we normally write here? Right, and what is it? X squared minus 6x plus 8, right? And then we would normally put a minus, and then we would put some parentheses, right? And what would we write there?
Minus 1.
Well, why minus 1?
That's what the...
Original problem was, right?
Yeah.
Yeah, what I'm saying though now is, see, normally we would put a number here, right? We would have f of 1 or f of 3 or f of 5, right? Okay, so what am I going to put in here now? Right, but what is f of c now? What do I do with the c? Plug it in. And if I plug the c into this, what will I have?
Squared minus 6c plus 8.
C squared minus 6c plus 8. So you know what I'm going to put here? I'm going to put c squared minus 6c. Yeah, this can be a little bulky, but trust me on this, it's going to work out really nice. Okay? Plus 8. Over x minus c. It did take a little bit of space, didn't it? And we're actually going to use up a lot of space here.
Are we going to factor out x and
Now,
c?
we are, but we're going to do that second. See, there's two ways, Austin. Oh, well, he knows we're going to do that because of what we have on the bottom here, right? All right, so here's the deal. There's two ways, well, excuse me, there's probably a dozen decent ways of doing this, okay? But we're only going to do two of them based on what you're capable of doing. We're going to solve this in two ways. The first one we're going to do is we're going to use synthetic division, like we've been using, right? Then we're going to use factoring, okay? So are we kind of ready to do this? The first thing I want you to notice is what is the first thing that we can simplify up here? Look at it, and I want you to notice that there's something that can be simplified. Yeah, go ahead.
I don't know what to call it.
The eights. Yes, the constants. Yes. Yes, the constants can do what? Yeah, because we've got a positive 8 here, and if we distribute this negative, let's distribute this negative. We'll have negative c squared, right? Plus 6c minus 8, and of course we'd have to get rid of these parentheses while we do that, right? Okay, so now we have 8 minus 8. That's awesome. So let's cancel them. 8 minus 8. And now what we have is the limit as x approaches c of x squared minus 6x minus c squared plus 6c over x minus c. It's getting a little simpler. We're breaking it down.
And then it'd be x minus 6 and c plus 6.
Brandon?
You changed the 6c to the plus in the...
Right, because it was, remember, we had minus c squared minus 6c plus 8. This is in parentheses, right?
Yeah.
And then we distribute the negative. When we distribute the negative, it becomes minus c squared minus negative 6c, which becomes plus 6c and minus 8. Okay, so now, all right, now what we're going to do is we're going to use synthetic division. No, we don't. We have one variable, x. C is not a variable. C is representing a constant. Yeah. So now, what should I put in the half box? C. I'm going to put a C. We always put whatever number's here in the half box, right? Okay, I'm going to put a C in the half box. What's the coefficient of x squared? No, the coefficient. 1. What's the coefficient of x? Negative 6. And now hang on. What? No, not negative 1. See, we would put... Right, and not even negative c. I want you... Watch, Adrian, look. Look at this. Adrian, watch this. Isn't this whole thing right here just a number? Like if c was 5, this would be negative 25 plus 30. So this would be 5, right? So what we're going to do is we're going to put this whole thing, negative c squared plus 6c, as a constant, as its own thing. It's taking up its own little space in the synthetic division line. Because it's a number, right?
Yes.
All right, Chaz, if x was 1, right? Then this would be negative 1 plus 6. This would be 5, right? Again, a 5. And so we would just put a 5 here. Yes, it's bulky. I get that this is bulky. But trust me when I say you will be happy in a minute, okay? All right, watch. Well, I didn't say you were going to be happy now. I said you'd be happy in a minute. Okay, it might be 2 minutes if it takes us longer. All right, now, let's just do what we know how to do in synthetic division. So what's the first thing we would do here? Drop the 1 below, right? And then what would we do with the 1?
DC.
Yeah, we are going to multiply it by whatever's in the half box, which is C. Right? Oh, well, it should be just C. Right? We got a 1 here and a positive C.
Right, no,
Yeah.
I did the math for the negative 6.
Oh, I see. Okay. Well, hang on a second here. Yeah. So C times 1 is C. And then we have to combine these.
I can't see.
Negative 6 plus C. Or is it okay if we do it as C minus 6? Yeah, these are not like terms, so we can't combine them. So we just have to write C minus 6. Right. No, listen. It is not too much. It is just bulky.
It's gonna be
Okay?
C squared minus 6C.
Yes, it is. Yeah. So now look. Now I'm going to multiply this times C. And what is C times C minus 6? C squared minus 6C. So I'm going to put that right here. C squared minus 6C. And guess what's about to happen? It's going to be, these are going to cancel and it's going to become 0. See? As usual. As usual. Right? Now, if we go up here, guys, if we go up here, this can now be factored, watch this, this can now be factored into x minus c, because it's always x minus whatever number's in the half box, right? This is the factor theorem. The factor theorem says that if you do division and get a 0 here, then that number, x minus that number, is a factor. So x minus c is definitely a factor. And then the other factor is what we see here. This is 1x to the first, right? Yes? Remember our power goes down by 1 in synthetic division? So it goes from x to the second power to x to the first power. So this is x. And then this is a positive c minus 6. So plus c minus 6. X plus c minus 6. Okay? All right. Maya, if there was a 5 here, wouldn't it be x plus 5? Okay. Well, instead of a 5, wherever you would put a 5, x plus 5, you just put a c minus 6.
It's the same thing you did with the C squared minus 16.
Yeah,
You
exactly.
made it one number.
Yeah, this is one thing. So, but now we can think of it as x plus c minus 6. It's all going to make sense in another minute. Now, what can we do with the x minus c? We can cancel. Oh, yeah, we factor it out now. We cancel it, and all we have left now is the limit as x approaches c of x plus c minus 6. Now, what is our last step? Plug c in for x, and we get c plus c minus 6. Say that again. 2c minus 6. So our instantaneous rate of change is 2c minus 6. And now, we can put any number in, right? So now, Chaz, what is the instantaneous rate of change of this function when x equals negative 10? It's negative 26, right? Isn't this good? This is good, right? Now, hang on. I'm going to teach you guys, hang on. I'm going to teach you guys one more thing. Well, we're going to do it another way, and we're going to come back to 2c minus 6. In case some of you don't know what just happened, we now have a rule. If I ask you what's the instantaneous rate of change when x is equal to 7, all you have to do is put that, right, 2 times 7 is 14, minus 6 is 8. So the instantaneous rate of change of f of x when x equals 7 is 8.
So like it takes
Yeah.
more work to get it started.
Right.
Even if you have to do all
Yes.
that, then it's a lot.
In 2 weeks, Chaz, we are going to abandon this. And all we're going to use ever is this.
Oh.
Do you see what I'm saying?
Yes, sir.
All right, think about, guys, listen. Think about a crustacean. Okay?
Mr. Crab.
You are nothing more.
Think about a crustacean. It's when it's born, okay, when it's small, when it's in what would be its adult form, like a lobster or something, right? It gets a shell, right? And then it grows. And what does it eventually have to do? It has to shed its shell. It has to molt, right? And then it grows a new shell. And it keeps doing that, as it keeps growing, right? So what's happening is we had to learn limits just long enough to learn instantaneous rate of change, and we learned that just long enough to eventually learn what's called the derivative. And once we know, we're molting. That's correct. Our knowledge is molting. Okay? Yeah, like Mr. Crab. That's right. Okay? All right. We're going to back this up for a minute because we still have plenty of time. We still have plenty of time. We're going to back up to here. Okay? Guys, we're going to back up to here. Do you remember when we were here? This was like step 2. And then we canceled the 8s, right? The 8 and the negative 8. All right, so now we're going to go back to the limit as x approaches c of x squared minus 6x minus c squared plus 6c over x minus c. I'm now going to show you how you can do this with factoring. Okay? Now, in order to do this with factoring, we have to rearrange this. It can't be done like this.
Do we have to do it?
Okay, what's that?
Do we have to do it with factoring?
I want to do it with factoring to show people, but just follow along, okay? All right, so look, what I'm going to do here is I'm going to put the minus c squared first and then the minus 6x next. Now, technically, you could do it in this order with factoring by grouping, but I want to do it with a different kind. Well, it's still kind of factoring by grouping, but I think it'll be easier for you to understand if we do the factoring by grouping in this way instead. I mean, it is still factoring by grouping. I split up the two middle terms, okay, which is not that big of a deal. All right, now, I want to make sure this is still recording. It is, good. Okay. All right, so look. What I'm going to do is, please watch closely. I'm going to put parentheses here and here.
So you're changing the factors.
Okay? What's that?
You're changing the factors.
Yeah, basically. I mean, it's still going to be the same factors. They're just going to come out differently. Now, what I'm going to do here is I'm going to put this negative with the 6. And then I'm going to put parentheses around it and put a plus in between. It still means the same thing. We're still at negative c squared plus negative 6x, which means minus 6x plus 6c. Okay? Now, once it looks like this, I can now factor. What is this? This is say it, Danielle.
Difference in
That's right. Thank you, Brandon. Brandon and Danielle. All right? This is a difference of squares. And so it's going to become x plus c times x minus c. Right? Now, I can't cancel the x minus c yet because I have addition here. Remember the house of math? I can't cancel from just one side because I've got addition tying this up. In order to cancel this x minus c, I need an x minus c here and here.
This is so easy.
It is easy. Now, I can take a negative 6 out here. If I factor out a negative 6 here, negative 6, what's negative 6x divided by negative 6? X. And what's positive 6c divided by negative 6? Negative c. And now I have an x. Yeah. Now I have an x minus c. So I can cancel x minus c, cancel x minus c, cancel x minus c. What's left? What do you see?
X plus c.
X plus c. Actually, let me put it down here.
X plus c
I have x plus c minus 6.
You plug in c.
That's right. Limit as x approaches c. And now just plug c in. And we get c plus c minus 6, which is 2c minus 6.
Why do you cancel both?
Because, look, if I have 4x plus 3x over x, I can't cancel just one x up here with this. If I had 4x plus 3 over x, there are lots of high school students that think that they can cancel this x. They can't.
Because then b 4 plus 3, that's not right.
Right, because there's no x over here. This addition is tying up. You can only factor out of, you can only divide out of multiplication.
You can make it 3 over x plus 4.
Yeah. Yeah, well, yeah, you could do 4, excuse me. What you're saying is you could turn it into 4x over x plus 3 over x, and now, yes, you could cancel the x out of just this side. Yes. Okay? So now, all right, so we are approaching the last thing. I want to be done in 4 minutes. Okay? I want to be done in 4 minutes. And I only have one thing left to show you.
Let's do it!
Okay. Can I get...
Wait, you covered
Sure.
the answer.
I am not, by the way, not going to erase this. For what I am about to teach you, I do not have to erase this. Okay? What I am about to teach you is a new kind of notation. And because it's notation, you have to see it. Okay? Well, let me say this. For some reason or another, I think I know why, but I don't know for sure because I'm not a history major and I'm not a math major. Okay? So I don't know for sure, but for some reason or another, over the last several thousand years, math people have this thing for shortening everything they write down into little tiny symbols. And I think the reason they do that is probably has something to do with, at a time, there was a limited amount of parchment or papyrus and a limited amount of ink, right? Or there are so many ideas in their brain that they want to get them out faster, so they write everything in shorthand. So instead of saying what is the instantaneous rate of change in f of x at x equals 7? Y'all, because not many of you are looking at me. Okay, so look. Instead of saying what is the instantaneous rate of change in f of x when x equals 7, this is what we write. We write it in just a few tiny marks. This is what we write. First of all, we're concerned with the function f of x. And then what we're going to do on the f here is we're going to put an apostrophe. We're going to put an apostrophe. Do you guys see the apostrophe there? What we call this is f prime. F prime. That's how we say this, f prime. And what that little tiny apostrophe means is, what is the instantaneous rate of change of? This little tiny apostrophe means, what is the instantaneous rate of change in f of x at x equals 7?
I remember primes being like after translations and graphs in like 8th grade.
Yes. Prime is a commonly used...
Just like after a change.
Something like... I'm sure it's been used in multiple ways, just like parentheses are used in different ways. But in calculus, it means instantaneous rate of change of. Yes. So this is basically saying, what is the instantaneous rate of change in f of x when x equals 7? And what is the answer again, Chaz? No, that was at negative 10. 8, yep. So f prime of 7 is 8. Now, since you bring up the negative 26, what can we say? We can say that f prime of negative 10 is negative 26. And what was the original one we did at the beginning of class? What x value?
3.
3. So f prime of 3 equals 0. Yep. Does this make sense? Yeah, it's just, yeah. Look at the quiz. On the quiz, look at question number 5, right? What did we get for number 5 again? Negative 2 or something?
Yeah.
Negative 2, right? And what was the function? Not what was the whole function, what was the name of the function? R of x. Okay, so question number 5 on that practice quiz, we would say R prime of 1. R prime of 1 equals negative 2. There we go. That's basically what you did on that test. And what you're going to find in calculus is eventually we are going to stop having this conversation and I am just going to say, here's a function. What's f prime of 3? And you're going to identify the instantaneous rate of change of f of x at 3. No, you do like it and you will like it. And you will have vegetables with it. Any more questions?
No.
We're done. Good job, guys.